Hello everyone. In this video we'll be looking at another diagnostic test for our calculus series. This time we'll be looking at important aspects of analytic geometry which show themselves when we begin to study calculus. To start, let's consider a line in the xy plane which passes through the point 2, -5. And suppose that this line has a slope of -3. Well, to start, we wish to find the equation for this line. Equations for lines take the form y equals mx plus b. Well, we know that m is equal to -3 because m is our slope. And further, we can plug in the values of 2 and -5 for x and y because we know that the line passes through this point. So it has to solve the equation y equals mx plus b. So plugging in, we know that there's an x value of 2 and a y value of -5. Doing so, this becomes, well, it's a -6 plus b. And this implies that b is equal to 1 because you can just add 6 to both sides. Then the total form of our equation is y is equal to -3x plus 1. And this is the line which passes through 2, -5 in the xy plane and which has a slope of -3. Now, suppose we wish to find the line which again passes through the point 2, -5, but which now is parallel to the x-axis. Well, the x-axis goes horizontally, and this means that m is equal to 0. So that our equation for this line is equal to y equals mx plus b, but m is 0, so it's 0 times x plus b, which is equal to b. And this is a line of constant y, because b is just some constant. Well, if we specify any point on the line, we have to specify a y value for it. We've already specified a y value of -5. And since this equation tells us that the y value is constant, we know that y is equal to -5 is the only solution to this equation. It is a straight line. Next, perhaps we want to find the equation for a line which is parallel to the y-axis and also passes through the point 2, -5. Well, if it's parallel to the y-axis, it goes straight up and down. So there's a constant x value. We've already specified an x value of 2 in the point 2, -5. So the equation for this line is given by x is equal to 2. And that is the equation for our line. Notice here that no y value is specified because this is true for all y values. Finally, suppose that we wish to find a line which passes through 2, -5 and is parallel to the line 2x minus 4y is equal to 3. Well, we first wish to rearrange this equation here in a more familiar form. Doing so, we find that 4y is equal to 2x minus 3. I've just rearranged this equation here. Then, dividing both sides by 4, we find that y is equal to x over 2 minus 3 over 4. So here, we wish to find the equation of a line which is parallel to another line which has a slope m equals 1/2. So we wish to find the solution to the equation y is equal to 1/2 x plus b. And plugging in for the x and y value that were already given, we put a 2 here, and y is -5. And we find the 2 and the 1/2 cancel to become 1. And so, solving for b here, we get that b is equal to -6. So, at the end, the equation for the line that we're looking for is given by y is equal to 1/2 x minus 6. So this was some examples for specifying one point in the xy plane and then specifying some other information, such as the slope of the line that we're looking to write an equation for. Now, however, suppose we're given 2 points. So for example, suppose that we're given a, which is equal to -7, 4, and b, which is equal to 5, -12. We wish to find the equation of the line which passes through a and b. Well, as is always the case in the xy plane, this line will be given by y is equal to mx plus b. Then we separate the problem into 2 cases. One where we first solve this equation by plugging in for a, and another where we plug in for point b. What we'll find is that we have to use the information from one of them in order to solve the other. So, plugging in first a into y equals mx plus b, we find that 4 is equal to -7m plus b. Or, rearranging this, b is equal to 7m plus 4. Next, we move on to plugging in for the b point into y equals mx plus b. In doing so, we get -12 is equal to 5m plus b. Now, plugging in for the b that we found on the a side here, we get that -12 is equal to 5m plus 7m plus 4. Then, we get that -12 is equal to 12m plus 4. Or, rearranging this, that m is equal to -16 over 4. Which, over 12. Which is the same as -4 over 3. So, we've found an m value here. Then, plugging that m value back into this equation to get what b is, we find that b is equal to -7 times -4 over 3 plus 4. Then it's -28 over 3 plus 4, which is equal to -16 over 3. Then we've found both an equation for b and a solution for m. So, plugging this in to our equation for the line, we find that the line which passes through both a and b is given by y is equal to -4 over 3x minus 16 over 3. So that is the line that we were looking for. Next, we will look at sketching certain regions in the XY plane, as this becomes a very important visualization tool when learning calculus. So to start, consider the region given by -1 is less than or equal to y, which is less than or equal to 3. Well, if we wished to sketch this, then we would proceed as follows. We first draw the XY plane, given here, and then we find -1 and 3. Well, -1 is here, and 3 is up here. This region contains both 3 and -1 because it's a less than or equal to sign. So, the region of interest is given by this shaded region. So any point specified within this region pictorially is found here in the XY plane, where it can lie on this line at 3 and -1. Next, suppose that we considered the region given by x, the absolute value of x is less than 4, and the absolute value of y is less than 2. Well, what this really means is that -4 is less than x, which is less than 4. And similarly, -2 is less than y, which is less than 2. Then, sketching this out, we again draw the XY plane. This time, we have constraints both on the x values and the y values. And we no longer have a less than or equal to sign. We have a less than sign. So I will be using a dashed line to indicate that points along this dashed line, which lie on the dashed line, are not contained in this region. So the region of interest is given by this shaded region, because all of the y values are less than or equal to this 2 value, and greater than or equal to this -2 value. And similarly, all of the x values are between this 4 here and this -4 here. So this region is really a rectangle in the xy plane, but we don't consider the boundary of the rectangle because of the less than sign. Finally, suppose that we wished to sketch the region in the xy plane described by x squared plus y squared is less than 4. Well, this equation, or this inequality, actually describes a circle, where here, this 4 is given by the radius squared of the circle. And this circle is further centered about the origin of the xy plane. So, drawing our xy plane once more, our region described by the above inequality, x squared plus y squared is less than 4, is given by the following region. Note that again, I'm using a dashed line to indicate that points along this line are not included in this region. So this is something like a shaded circle in the xy plane with a radius of 2, where we don't consider the points that lie along the edge. So this concludes this video on a diagnostic test for analytic geometry for this calculus series. In the next video, we'll be discussing functions and information you should know about general functions. Thank you.